Okay, so once again, we're going to do quadratics. So what are some ways that we can solve a quadratic equation? Quadratic formula. Boom. Come on. Factoring. What's the other way that we can do it? Completing the square. Those are the three main ways that you can go through it. Okay? Completing the square is probably the one that most people don't use as often, so that's what we're going to concentrate on the first part today, just so that we can get into practice. Okay, so you three rows over here, 1, 2, 3. I'm going to have you guys tell me what is x plus 7 squared, x minus 5 squared, and x minus 2 squared. What does that equal? You three rows, x minus 8 squared, x plus 1 squared, and x minus 12 squared. Okay? I'd like you guys to tell me what that is as a quadratic equation, meaning x squared plus 7x plus 12 or something. You get what I'm saying? So remember, does this mean that this is x squared plus 64, Mr. Romer? I can just bring in the square. Can I do that? A lot of kids try to, but remember that this is equal to what? X plus 8, excuse me, x minus 8 times x minus 8, and then what are we going to do on that? Then we'll do the distributive process or FOILing, right? Does that make sense to everybody? Okay, I'm going to push pause and get this stuff, okay? We're going to be looking for a pattern. So on the bottom, this one, what did you guys get? Let's go right here. Careful. 7 times 7. You're okay. Bailey, Michael Bailey. Next one.
X squared minus 10x plus 25.
Okay, Ryan. Good. Okay, let's come over here. Let's go. Oh, coming in. Cameron, go ahead. Okay, Miss Red, what's your name? Madeline. That was so nice, Cameron. Thank you. Madeline. Macklin. No, Macklin. Dang it! My Macklin. All right. Good. Last but not least, oh, pink shirt again. How many name again? Camden. Bet. Got it. All right. Hey, can we see the pattern? What is the pattern, Mr. Black Shirt? Tell me your name again. Ben. I could do that. I'm looking for a quicker way. Did you see it the quicker way? Okay. So basically what's happening is this guy's being squared. These guys are being multiplied. Then it's doubled. And then this guy's being squared. Now, were you right, Ben? You were. I'm not saying you're not. But I wanted to see if you could see the pattern to get there. Does everybody see the pattern? Basically, once again, this guy squared, timesing these two, as you said, double, then squaring the last term, correct? So, if that's the case, what would this be? X plus b, b squared. 2b? 2bx or 2xb, right? Plus. I got a check mark in second grade. We used to get stars or check marks. We got 4 stars, we got prize, 4 check marks. They said I was doing that. Okay, this is called binomial square. This is called perfect square trinomial. Okay, Now notice, what if I had this? Because it's the same way. Listen to what you guys said. What do we do to this guy? Square him. So what do we do to this guy? Square him. So what's 3x times 3x? 9x squared. Then we times these and then do what? Double it. So we times these. 12 and then we double it. So therefore, plus 16. I believe this guy was actually on your homework. Okay. But notice, we can do that. Now, I'll be honest with you, I will never complete the square with anyone but a 1 coefficient. Because if not, it's not worth it. Okay? Does that make sense to everybody? So, with that being the case, somebody help me here. Fill the blank. What would go there to make that a perfect square trinomial? How do we do that once again? If we looked at the pattern of the other perfect square trinomials, remember we doubled a number to get to here, right? So if we cut him in half, that would be my value that was sitting right here, correct? So it'd be x minus 8 squared. So therefore, remember, doubled squared. So this would be 60. Okay? So, hence, if we cut him in half and double, and not double him, cut him in half and square him, that'll be what fills the blank. Yeah? Okay? One more. You guys are like, stupid fraction. That's what you're saying right now, right? Let's all agree on it. Let's all agree. Okay, so really though, are fractions really that hard? They're not hard, they're just tedious. Meaning there's a few extra steps that you're gonna have to work with, right? Just give me a second here. Thank you. So let's really quick go through the fraction rules. When I add fractions, what do I gotta have? Common denominator, right? I think of Arnold all the time. Right? And then when I multiply fractions, what do I do? Straight across, correct? And when I divide fractions, times by its reciprocal. I never really want to divide by a fraction, I want to times by its reciprocal, correct? Okay, so remember, in our last step, we would be cutting the 3/2, dividing it by 2. Do I want to divide by 2? I want to times it by a half. What's a half of 3/2? 3/4. Now, I'm going to tell you right now, ladies and gentlemen, I am not a decimal person. If it doesn't start with a decimal, you should never have a decimal. Okay? So, once again, if I was writing my binomial squared from this, this would be x plus 3/4, right? So what would fit the last part to make it a perfect square trinomial? 3/4 squared, which is 9/16. So we're still in the okay? You don't like bubonic, Garrett? Sergeant like margarine? You guys know bubonic is a margarine, and it's also a flour. I didn't know it was a flour. I knew it was a margarine too, and then somebody's like, "Did you know that was a state flour, Texas?" And I'm like, "Shush, we're Texas people." Is anybody from Texas? Because I'm going to give you hell. That's the way I am. Arizona, you might be okay. Only the mosquito. Okay, here we go, guys. This is our first type. What we're really going to be doing. Are you okay first off, or do I need to go back? Yeah, to what?
So,
isn't dividing by 2 the same thing as timesing by a half? Because is 6 divided by 2, 3, and 6 times a half, 3. Sometimes if you think about it in normal numbers, it helps you real life. Did I help you or no? Do I need to do it again?
No, I got
Somebody's really stepping up there today. Look at this thing. It's like it hurts me. All right. Okay. So now we're actually going to do our first question of the day. All right. Now, on your homework today, there's going to be sections that may say, choose any method that you would like to do to solve this quadratic. Okay? Or they might say, please solve this quadratic equation formula. Or they might say, complete this by completing the square. Okay? Could I solve this one by factoring? Factors of 21 that give me to be 12? So could I do it by factoring? No, that's my favorite way to do it if I have an opportunity. By the way, if you can factor, you can do it by the quadratic. You can do it by the math. You can do all of them by completing the square, but again, there's certain criteria that I want to do to make sure that. All right, you guys know that's where the quadratic formula came from, was completing the square. You want to see it really quick? Okay, here you go. So here's your basic quadratic equation, right? With me? Okay, so once again, I always like to have my a term, this term be 1. What I'm going to do is divide everything by 8. Okay? Is c over a half of this guy squared? No, so I'm going to get him to the other side. Okay? So to fill in the blank, remember, I would cut this guy in half. What's half of b over a? b over 2a. Does that make sense? And then we square him. So that would be the b squared over 2a, excuse me, it'd be 4a squared. Because remember, half of it would be b over 2a, so squaring it would be b over 4a squared. Let me erase that nasty thing. Do I ever expect you guys to know this? I just want to show it to you. Because some people are like, how did they ever get this? Okay? Then, if you recall, this, if I do this to this side, I have to add to this side, because if not, I change the equation. So I got to add b squared over 4a squared. Here, it is now a perfect square trinomial, so this goes to x plus b over 2a squared equals, I'm going to get a common denominator here, so this guy needs another 4a, so I'm going to times the 4a top and bottom. They have a common denominator. b squared minus 4ac. Okay. How do we get rid of squares? Square root it. And when I take a square root, don't I have to do a plus? So what is this? X plus b over 2a equals, oh, this is a 4. I forgot to write down the 4. Plus or minus square root of b squared minus 4ac all over square root of 4a squared is 2a. Then I need to get this to the other side, so I have x equals negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. Because they have the same common denominator, so that's where it comes from. Okay, it's not just this random thing. They're like, how did they get this thing to work? Okay, they completed the square on the generic form. Okay, now would I probably ever thought of that? Not only no, probably no. But just understand it can happen. So we're going to do the same thing here. We're going to do, hey, it didn't factor. I could do quadratic formula, which we are going to do, but I want to do it by completing the square first. Okay? So is this a perfect square trinomial? No, what number up there makes it not a perfect square trinomial? The 21's like, ah, crap. What does it need to be? It needs to be a 36, doesn't it? Because if I cut 12 in half, -6, excuse me, it should be -12. -12 cut in half is -6. -6 squared is 36, right? Is he a 36? Can we make him a 36? Yeah. Ready? Add 15. If I add 15 to that side, though, what do I have to do to this side? Add 15. Because I got to balance him, right? Does that make sense to everyone? So this is x squared minus 12. Oh, come on. I'm struggling today. I apologize. Is this equation and this equation the same? Yes, they're equal to each other. They just look different, don't they? Right? Okay, but what did we call this side on the left side? What did we call it? A perfect square trinomial. And we can make a perfect square trinomial go into a binomial square. Which would be, what would be our binomial square? X minus 6 squared equals 3. Once again, I'm making it look different, but still equivalent, right? How do I solve for x there? Square root it. Remember, when I take a square root, though, what do I need to do? Which a lot of people forget, right? Okay. So I'm at x minus 6 equals plus or minus root 15. Sometimes I wonder if it's me. Okay, root 15. Can root 15 be broken down? What's in 15? 3 and 5. How many of us have Miss Merkley again? She would like say, 1 gets shot! Or something like that. I don't know. Right? You got to have buddies to get out of jail, and 1 gets shot! But there's no buddies. They had no buddies. It's weird, but I just tried, yes, getting the memory back. Okay. So then, as somebody said, then add over the 6. Right? There we go. Once again, we've seen this before. Might be a long time ago, maybe like 6 months ago. But is it somewhat deep in your brain? At least you've seen it, and now you're like, bring it back up to the top, right? Okay, I'm going to show you that we can get the same result. Okay, once again, what is the quadratic formula? X equals negative b plus or minus square root of b squared minus 4ac all over 2a. We're all going to sing it right now. You're going to sing it right now with Papa Bill. My teacher in 11th grade, I don't remember her name, but I can still picture her. Does anyone on the quadratic formula? No. Okay, so we're all going to sing it. If you don't sing it with me, I will kick you out and make you sing it later. So it just goes to just try it. Ready? Everybody? Everybody! If I see you mouthing it, I will pick on you. Okay. 1, 2, 3. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Don't be embarrassed, people. Miss Spangler, who used to teach here, she would never see me. I'm like, you're so silly. You sound more silly not seeing it than have me come in to see it for you. She would never think it. Okay, so here it is. B squared minus x equals, some people say opposite b instead of negative b. What does opposite mean? Just means like if you have negative 8, what's the opposite of negative 8? 8. That's what that means. So negative b, opposite b. Okay, with that being said, we had what equation? I'm going to use the exact same one. It was x squared minus 12x plus 21 equals 0. We're going to do the exact same equation. See if we get the exact same answer. We're just going to do it a different method, right? So we need to know our a, b's, and c's. Who is my a? It is not x squared. It is 1. It's the coefficient in front of x squared, right? Who's my b? Negative 12. Who's my c? Okay? Everybody with me? Understand where those values came from. Okay? Here we go. I even sing it as I plug it in. X equals negative b plus or minus square root of 12 squared minus 4 times 1 times 21 all over 2 times 1. Yes? Oh, fricker, fracker, frickers. That's another method, isn't it? Now, once again, it gives you options on your homework, and sometimes it doesn't. So some of them say solve by some solve by quadratic formula, some say solve by factoring, and some say choose. Okay. All right, so then we're going to do it. Here we go. I like to always just put all this stuff up here. I have 144 minus 84. So that'll be 60, huh? So I have 12 plus or minus root 60 all over 2. Can I break down 60?
Yes.
Yeah. Because what's in 60? 10 and 6. 5 and 2. 2 and 3. Buddy. See, there's enough buddies to get out of jail, and then one gets shot. That's what she would say. Because some people are like, well, there's 2 of them. Why is there only one outside? Because he gets shot. Okay? He lives in West Valley, for crying out loud. I'm sorry if anybody has family. Area of peace, would you go? I'm sorry. Do you have family in West Valley? I do. He's a little weird. He actually had a guy try to steal his car and he was going to shoot him, so exactly. All right, here we go. 12 plus or minus 2 root 15 all over 2. How did I get the 15, ladies and gentlemen? Notice the 3 and the 5. They don't have buddies, so I got time to get that. Okay. Now, does this guy, and this guy, what do they all have in common? 2, and so that gets us down to be 6 plus or minus root 15. Is it the same answer? Should it be the same answer? Yeah, because it's the same freaking equation. It's 73. And every time you guys come in here, it gets even hotter because there's warm bodies. All right. Hi. It is not. It is not. It is not. There we go. Because once again, ladies and gentlemen, first off, see how it's already solved for x squared? There's not an x term. You see how it's not a trinomial, it's a binomial with no x term. If it's that case, I can just jump right into solving. Okay, how do I get rid of the 4? Subtract it. Okay, so I just subtracted the other side. Okay. Now, is this a real solution? Why is it imaginary? Now, I really wish they wouldn't have called them real and imaginary because some kids are like, what are we using it for, man? Just want to kick you in the shins. Okay? So, first off, they are useful. They're very useful. I don't know how to use them because, guys, this is my notebook. Touche, huh? If you know an electrician, they might know. I have no idea. But that's what I've been told that they're at a lot. Anyway, but why is this not a real solution? Can somebody give me an explanation? Let's pick on, you haven't talked to me a lot today.
It becomes like if you're trying to do one on the
Why?
because
Okay, so that's the key question I'm trying to look for is can anything squared ever come out be negative? Because you'll take yourself, whether you're negative or a positive person, right? And you square yourself, negative times a negative or a positive times a positive will always come out what? Positive, so how could it be negative? That's what makes it the imaginary, what we're thinking, right? But we do understand that there's an imaginary system, okay, that we can continue going on. So we just take the square root, and once again, when we take the square root, what do we need to do? Plus or minus. Okay. Yates, you good? All right. You seem bored. I can give you a board game. I have a clue somewhere. It's mathematical. It is. It's logical. Okay. I cheated one time with my mom, and she told me she knew. I was 6. I'm like, okay. She was on the phone call, and I'm like, hurry and checked in there, and I went there on my very first time. I'm like, this is like, how did you know? Square root of 4 is 2, but because it is a negative, it makes it an that is correct. Good. I can help you.
I'm just wondering why.
Okay, do you want me to go through that list really quick? Okay. So I is just square root of -1, which we just call I still, right? If you recall, I squared is -1 because we put a square root on a square root. Right? And I cubed is -I because it's I squared times I. That makes sense? I squared times I, what's I squared? -1 times I. And then we have I to the 4th, which is 1, because it's I squared times I squared, which is -1 times -1, which is 1. And then what's I to the 5th? It's the same thing as I. What's I to the 6th? -1. All you have to do is divide by 4 and see how many times it goes into it. If there's a remainder, if it's remainder 1, it's equivalent to something like this. If it's remainder 2, it's equivalent to I squared. Remainder 3, I cubed. If it's remainder 0, I to the 4th. Yes, sir.
okay, so but I think the square negative not necessarily for why don't you just for I?
Okay, got you. Let me hurry in. I see your question. Give me 1 second. So, is not the square root of 16 square root of 4 times square root of 4? You can break square roots apart, right? So, if I had square root of -4, is that square root of 4 times square root of -1? And hence, 2i. Does that answer your question? Okay. Everybody with me on that? That's fine. Anything that comes out as a negative underneath square root, it's going to have the I because I could just factor out the negative part. And then that will make it. Okay? All right. Good questions, guys. Good questions. Really quickly, how many solutions could come out of an x squared or a quadratic? 2. Okay. Not 4. Never 4. The highest you could ever have is 2. Could you have 1 real solution? Yeah, because sometimes, let's say you do the quadratic formula, and it comes out 4 plus or minus square root of 0 over 2. Right? And that would be 4 plus or minus 0 over 2, which is 4 over 2, which is 2, right? But we actually call this a multiplicity. It's actually 2 zeros, but at the same spot. Because you have 4 plus 0 is one solution. 4 minus 0, different solution, but they're the same number. So graphically, this would look like such. It's crossing at 2. You just have your vertex at 2. We're going to get into what we call this. It's called a multiplicity. We'll get into that coming up, I believe, in our second. Or it might be in our first. Okay. How many solutions do we have with this kind of graph? 0, but that's 0 real solutions. But how many imaginary? Because every quadratic can always have 2. Right? It might be 2 imaginary, but it's still 2 solutions. Does that make sense? Okay? So you would say 0 real, but 2 imaginary. Okay? How many on this one? 1 real, but a multiplicity of 2, meaning it's the same 0. Does that make sense to everybody? It's slightly different. And then we have, obviously, how many times on that one? Twice. Okay. Good? All right. So, give me a starting number, Miss Jasmine. 3. Give me a back number, Mr. Balamas. No. Right? Close, though. Balamas. 20? That's not that bad. Okay. We're going to factor in. You guys made this problem up. Okay, so the factors of 60, right? You guys see how I got 60? 3 times negative 20 gives me negative 60, right? Factors of 60s are 160, 230, 320, 415, 512. Can 6 go? 6 10s. Can 7? 8, 9, 10's on the other side. Notice I went all the way until I wrapped around, correct? Once again, that happened to you this morning, right? You forgot to just go all the way down. So you were another person came in as well. So just remember to take your chart all the way down until it wraps around, okay? All right, which is the pair that is going to get me to 7? 5 and 12, right?
Oh my God.
Didn't get to
The screen is what scares me.
understand. Stay on your toes. People that have driven with me understand. Who's drove with me? Anybody in here? Did I do it to you?
I drove.
No. Who else did I drive? Heather, did I drive you? Just one day, then you hated me and you're like, screw it. Oh, with Atkinson because the car broke down, huh? No. Oh, shut up. Don't mock me. It's in the afternoon, sometimes that happens. If you have me in the morning, I never fall asleep. Okay, I've been doing really good. I've been bringing sunflower seeds. So I chew away. What do these guys have in common? Left with x plus 4. Do we see how it's a negative 5? Now, once again, did you guys notice that it doesn't matter which way you put them? Just in the end, it'll mean that they're commutative. At the end, it'll come out opposite, meaning this times this and so. All right, ladies and gentlemen, what's the difference from yesterday and today?
That's where we stopped yesterday because there was no equal sign, was there? We were just factoring the expression. Today, we have an equation. Because we have an equation, that means we're not done, huh? Because we know what x is yet? Isn't that what our goal is? So, I set each of these equal to 0. Why? Well, this is saying this binomial times this binomial equals 0, right? How do things become 0 when you're multiplying? This guy has to be 0, or this guy has to be 0, right? That's the only way to get to 0 is something has to be 0, correct? So what I do is I set him equal to 0 and say what value makes that guy 0? What value makes this guy 0? Well, this one's pretty easy. What value makes this guy 0? Negative 4. This one we have to do a little bit extra work, don't we? Adding the 5. And then divide by 3. That shirt that you're wearing, something Mia, reminds me of, it was my sophomore year. I went on a girls' choice date and they shared this shirt with you. She was wearing one like that and I had a white one on the opposite. Oh, it was nice to see you. She was a very nice young lady. She lives out in this area now. I don't know her new last name. Hey, this time we're going to go backwards. I'm going to give you the solutions. And I want you to write a possible quadratic equation. So this time, I give you the equation. And basically, what am I asking you to do? Go backwards, right? Like the last time I gave you the equation, we found that I gave you the solution. The equation, we got the solution. This time I give you the solutions, I want you to go backwards. Okay? So what do we do? Anybody have an idea? I'm going to see if 2 other hands. I've heard you guys a lot today. Give me a second. Jasmine, go ahead. I haven't heard you. I've heard you once, I think. So how do I get out of this state? So I want him to be 0. Now on this guy, I could just add 3/4 over, couldn't I? That's not what I want you to do. If it's ever in a fractional form, let's make it so that there's no fractions in it, okay? So what are we going to do? Times the 4 over first, okay? Sometimes it's better when I don't look. I think it's better. Okay. Then what do we do here? Add 3, and just as Jasmine said, we want them to equal 0, right? Okay, those are my binomials, aren't they? Right? Then I'm just going to distribute. I made him work. There we go. Now, do you guys understand that's a possibility of an infinite amount of solutions? Think about it. Let's, once again, what was the zeros that was? Negative 3/4 and 2, right? So let's say this is crossing at negative 3/4, this is crossing at 2. So here's one graph. Still the same graph, just wider. Inverse. Flipped over.
right? There's an infinite amount of those that could be that. We just chose a specific one. To get to those infinite amount of ones, I just have to times this by a certain a value out here, meaning another number, and I can give you the infinite amount. But this is exactly what I'm looking for. Okay? I just want you guys to understand, there's not just one right solution. There's actually an infinite amount. Unless alternative solutions. Okay? You guys feel comfy? All right. That's it.